Thank you, my mentor and teacher, Professor Alauddin, to coming here from the just arrived from Sulfuric to Dhaka. So last night we talked with him and he was able to come in here. And then I'm not going to talk about the background, so that my previous speaker nicely explained why we are moving to that renewable energy and what is the role of the battery technology or the lithium. So I'm going through that the topics, the details. My presentation will focus on. So I'm going to talk about that the industrial overview of the renewable energy, especially the battery industry, what's going to happen in the next 10 to 15 years to increase the renewable energy in our current existing energy sector. So what is the role of the lithium-ion battery? And inside the lithium-ion battery, why we use the lithium metals as a central metal for this lithium-ion battery. And this lithium is the key metals. What's the supply currently available? What's the demand? And then demand is increasing in next 10 to 15 years. So what will be the supply sources of this lithium? And then resources means the lithium is sitting in all over the world. Especially a couple of countries, they are controlling the lithium resources. But if you look at the first world, who is controlling the most of the cases in the renewable energy sectors, especially USA, Canada, Australia, and European countries, they are going to develop and they are developing the technology, but they don't want to keep these materials in a certain political region, in a certain countries. They want to look where that reasonable resources sitting, and then how we can use these materials efficiently next 10 to 50 years. So then I will move to the technology. So what is the role of the lithium and how it is playing in the renewable energy sector? But behind that battery industry, the main source, that is the lithium metal. What are the sources? I will discuss about the source, and then I will move to the technology, how these materials or metals produce from the different resources to fill the existing demand. Then there will be a summary of this presentation, the challenge and opportunity for Bangladesh. There are a couple of things I will discuss one by one. So this is that overall picture of the lithium-ion battery. So what happens? Sometimes the people talk about the lithium-ion battery or battery sectors. What is the relation between the renewable energy and the lithium batteries? You see that the battery made with some other metals, that battery can be used for different sectors and currently using in different sectors too, but the use of these battery materials is expanding very rapidly. It's not only for the use for the electronics. If you see that the last corner of this one, so renewable energy, so we can capture this energy from the solar or wind, but it should go to the grid, right? But that can, sometimes what happens is not directly using this produced energy, so it should be reserved. So we call that a storage. That storage is also based on the lithium-ion battery or other batteries. So if you capture this energy, it should be properly store that one, and whenever you need, you can use that one. So what happens that the electronics, for example, the computer, the charge is not in there. So what is the role of the charging? So you have a battery that is connected with the source of the electricity. So you are charging this battery. So later you are using this battery to run this equipment or electronics. So it is charging and discharging happening through this battery. So that battery is made with some special critical metals. The center of these metals is the lithium metal. So we already talked about the application of the lithium, and there is a wide nickel. So it's not only one metal used for the lithium-ion battery. There is the other metals too. The one of the other metal is the nickel metal. So that's why I put in nickel. Just let you know. So nickel is also part of the lithium-ion battery. The rapid development of clean energy technology, that is the lithium-ion battery, has a significant increase in demand for critical metals. The use of lithium-ion battery and nickel is increasing in making lithium-ion battery for EV and energy storage, while they're easily extractable. What is that? So this is a little bit different. So the source of the lithium metal is totally different. In the location, some of the sources are very easy to extract. Some of the sources are very critical to extract because of the other metals are there. So when you use the lithium metals to making the battery, the metal should be very highly pure. If it is not pure, it will impact on this battery. It will have some important disadvantage that will reduce their lifetime. That's why the processing of these materials depends on the resources of the metals. So last 10 to 50 years, people are using very easily accessible and very easily extractable resource to make this lithium metal. But the time being, the resource is very limited. That resource is going down, 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 but the demand is going up and up and up. That's the biggest challenge nowadays. So you can see that last corner. So how the importance of these metals used in a different, very critical materials making. So it's not only the battery technology depends on the metals, you know, the magnet. So in a solar wind, so the wind power, wind is generating so much power, and then others are also generating the power. There is a significant amount of metal used to make the magnet. That magnet is nothing, but there is lots of valuable critical metals. So we call rare earth metals. Might be you saw the periodic table. The lanthanum to lutetium, there is a lots of metals. They have the very important and critical characteristic that is called magnetic properties. Based on these magnetic properties, we select the metals to make these materials to capture the energy from the solar output. That energy we store in a battery. That battery is made with the lithium. So all are integrated is our. So lithium is used almost 54% for the battery industry. Whether this battery is used in electric vehicle or electronics or storage. Okay? So now question is what happened? You guys know might be the Tesla is going very fast to sell all over the world. Why Tesla cars are very, very important for nowadays and is going to increase their product very rapidly. Because no one will use now is the oil price is very high, almost double. They want to use the renewable source of the energy to charge their battery and run for 2-3 days, depending on how much mileage. That battery is based on the lithium metal. So why lithium? I will explain that one. So based on that, they are selling current status of the based on lithium-ion battery-based electric vehicle. So other companies, car companies are losing their sales. losing their revenue. So you see in that, in Bangladesh especially, I think 80% cars made by Toyota. Now Toyota is a big challenge. They are facing very big challenges. It's not only the Toyota, all European car makers are facing big challenges because most of the cars based on that fossil fuel. So they are slowly moving through the renewable energy, means battery-based electric vehicle. So what is the source to make that the battery? So that the lithium is one of the most important metals to make this battery. So that's the part. How this battery made. If you see the batteries, the structure, there is a cathode and anode. Now most of the anode is prepared or made with that also graphite. But the active material we call cathode, then the cathode is so many different. But the central one is lithium and cobalt oxide. The other one is iron lithium phosphate. The price of the iron lithium phosphate is much cheaper. But the density of these metals, charge discharge capacity of this metal is less. If it is cheaper, but its efficiency is less. But they will move to a lithium cobalt oxide based battery. The cobalt price is going very high and fast. So if you are in a market, you want to sell your price, you should be competitive with the others. So, but your production cost is going up because of the raw materials price is high, then you cannot sell this material, your car or other product based on the current existing value. So you need to reduce. So you look what are the points, what are the options that can help you to reduce the price. The one of these, the cobalt price is going up. If you think you can replace the cobalt by other metals, by keeping the lithium into the system, might be there is a chance to reduce the price. That's why scientists are developing every day. This is a very rapid developing field to replace current existing battery materials by other innovative metals. That's why you see the different. The last one is mixing of lithium, cobalt, nickel, manganese oxide. So what happens in that cases? Nickel, manganese is replacing by, cobalt is replacing by nickel and manganese in certain point to reduce the price. But still they are getting very good charge discharge and lifetimes. So before moving to that, why lithium? Why not other metals like sodium, potassium? If you see little bit chemistry, I believe you start in the grade 10, 11 or grade 7, 8. There is a periodic table, little bit chemistry. So these are lithium, sodium, potassium, rubidium. These are the alkaline metal we call. The chemical structure is very similar. The outer shell has one electron, but still lithium is special compared to the others because of the size of this metal, and it has the special characteristics of electrochemical properties that give very special application of this metal in this industry. You see, most of the metals, lithium and metals are using passenger electric vehicle compared to the other applications. It is assumed that lithium demand is forecasted to increase 15% per year through 2027. Can you imagine? Every year is going to increase 15% of this lithium in this industry. It means so 4 times is increasing of the total demand. So, for example, now the electricity is gone. What will happen? You still want to keep that your AC on, lights on, how it is running. So the power you are storing into somewhere, that is the battery. When the electricity is available, you charge this battery. When it is not there, then you run all these lights and electronics based on the batteries, right? That things are happening more rapidly. That's why the lithium price is going up, the demand is going up, and then they estimated that by 2027, 78% battery demand will be increased. So it means next 5 years, what will happen in this industry? So little bit different. So metal is not using in this battery system. So it's not in the elemental metals we use for these purposes. The metal has two different compounds. One is lithium hydroxide, another is lithium carbonate. These are the two products we produce to make the lithium ion battery. The first one shows that, okay, so before moving to that, so how we get the lithium hydroxide and lithium carbonate? Mainly the primary resources we got naturally. That is the brine, maybe you know. The another one is the hard rock. That is the soil sediment and under the ground. The one is liquid, that is we call brines. The other one is solid, that is the way we call rock or ore. So everybody wants to get this metal very easily by spending less amount of money. That process depends on what is the source of this metals. If it is brine, it's easy to access, easy to produce these two products, and lithium hydroxide and lithium carbonate. But if it is rock, it's very hard, and you need to develop the technology to get these metals. That's why the cost is high. But the brine is not in everywhere. There is sitting in a couple of countries. Geopolitically, they will control, or they are controlling the production of the lithium hydroxide. If something happens, then other countries will not get the access of these materials. That's why the more countries moving from brine to hard rock, because the hard rock is sitting in all over the world. So why are the hard rocks and the other metal, others the brines are sitting in all over the world? So who is controlling or contributing the production of lithium source, that is the lithium hydroxide and lithium carbonate? The number one is Australia. They have almost 50% resources based on their ore, not the brine. It's sitting in the underground. They have 50% resource of the lithium. The second one is the Chile. They have about, you see in here, 22% of the lithium in a lifetime. The Chile has so much brine and easy to access, easy to get the lithium hydroxide and lithium carbonate. That is 22%. The third one is China. Fourth is Argentina. In China has that hard rock, and Argentina has again, that is the brine. These are the main controlling players. They produce, they have the reserve of the lithium resources. And who produce? What are the companies produce the lithium hydroxide and lithium carbonate? If you see the bottom bullet point, I don't have the pointer, so that's why I have to show you. So one is then there's the Galaxy resources. I had an opportunity to work with these guys to develop their flow sheet through the bench scale pilot plant and demo plant to move to the commercial plant to make lithium hydroxide and lithium carbonate. I was working last 3 years with them. Then now they moved to commercial plant to produce lithium hydroxide and lithium carbonate in Australia. Lithium batteries available for recycling. So what we can do? We don't have the resources, whether it is hard rock or brine. Might be we have a brine in the coastal area, but the concentration of the lithium in these brines is very, very low. Maybe that brine is not economically viable to get the lithium product because of the cost will be very high. The density of the concentration of the metal in the feed solution is very low. But this industry is moving very, very fast. You guys want to use one what's called mobile, and then we're looking for 2, 3 mobiles. What is happening? Because the first one is already charged is gone, or you are using additional batteries, right, to charge it, keep it active. So it is all about the lithium-ion battery. So we already in that industry, we are producing huge amount of waste lithium-ion batteries. The metals is not destroyed. The characteristics of the metal might be changed. That's why everything has the half-life or life cycle, right? So 1,000 times or 10,000 times you can charge and discharge. Then your activities, the battery activities is going down, down, down. Then it is the waste. So what happens that waste? The waste is containing mainly the critical metals, the precious metals like lithium. So we already in that industry, not based on the natural resource, but it is based on the waste material. So next 5 to 10 years, you will see so many electric vehicles running. When I come in this country 4 years ago, I saw very little cars running based on that hybrid or plug-in hybrid. Now I saw so many cars running hybrid and plug-in hybrid. What is the meaning of hybrid and plug-in hybrid? There is a battery in addition to the your fuel. And plug-in hybrid means so that battery you can charge and discharge. So in the night time or whenever the charge is going down, then you charge this. That's the difference, the hybrid and plug-in hybrid. So battery is already there. After 5 years, that battery will be the waste battery, but metals are sitting in there. But there's a way that now is moving to the fully electric battery. Especially it will come to the government big process. They will access this battery, they will bring that in technology, and they will put that industry. So we're going to generate after 10-50 years huge amount of waste materials that can be used by recycling, reprocessing to make fresh battery. So this market is big and expanding huge. It's not only for the technology, it's related to every sector. Every single sector. It's not only that based on the material science and engineering, it is based on that, for example, mechanical engineering. So you guys are working, your target is to work in that, what's called aircraft or all these industries. Now so many years, they're thinking how we can use the solar energy instead of fuel to run your aircraft. What happened there? So you're going to use that precious metal to make the solar panel, and then the solar plus capture that wind or sunlight to producing the energy, and there is a high storage battery you're keeping or storing, and that energy you're using to run that craft. So you are not far from this industry. You are integrated, your life is integrated with this system. So I'll move to the technology of ORGANISED. It's a little bit more scientific. I'll try to explain very simply. So first one is the brine. So significant amount of brine sitting into the Chile, Argentina. They are controlling currently to produce the lithium hydroxide and lithium carbonate to sell to this industry, especially Tesla is using their product to make their battery and then run their electric vehicles. So these are the metals on the left side. The first one is Li, means lithium. And the right side, the location you see that the brine sitting in USA, Chile, Argentina, and others. But if you see the concentration of this lithium is 0.11 for Chile. 0.11 means we call gram per liter. It should be in somewhere. So the all figures in weight in percentage means 0.11 to 0.31 percentage means 1.1 gram per liter to 3.1 gram per liter. This is the concentration of the lithium in the brine, the highest concentration compared to the other countries' brine. The other one is the hard rock, that is the sediment underground, sitting into the underground. That has different minerals. Little bit again, this is a little bit different. So every metal sitting into the hard rock is associated with the minerals, not metals in a single phase. Is associated with the minerals. So that mineral is the key mineral, what's called key compound to develop a technology to get this metal from the source to make it high pure product for application. So spodumene, we call spodumene or spodumene ore, means spodumene mineral mainly contain lithium metal in a hard rock. The other one is secondary resources. I talked with them that so we are producing significant amount of recycling materials. That is the main source will be in next 10-15 years to regenerate, reuse, recycle to this industry. How we make that lithium carbonate? So there is a two products we produce. One is lithium carbonate, other one is lithium hydroxide. Before moving to the lithium ion battery, these two types of compound we use to make the lithium ion battery. The first is the lithium carbonate. The brine is the one of the most important source to make the lithium carbonate. It goes through different subsequent process steps to purify lithium in order to produce the lithium carbonate. The first one is that there is so much impurities. It's not only the lithium sitting into the brine, there is other metals such as iron, copper, calcium, magnesium, zinc, all these impurities. If you want to make this product is very hard. So you are a businessman. You want to sell your product to the market to get more value. So your product should be special compared to the others, right? So how you will get that your product is very good? So it doesn't matter it is a lithium product. So any product that should have a special properties or a special characteristic that is different from the others. So similar to this one. If there any other impurity metal coming with the lithium carbonate, the price will be go down because the properties will be different. It will not play exactly the way it should produce the energy or capture the energy or store the energy. So how we remove and how we produce this? This flow sheet is very simple, but for you it looks like very tricky. But the process step is that we remove the impurities by increasing the pH. So higher pH, most of the metals are precipitating. So depending on the pH, with the calcium hydroxide, that is the easily accessible, and the price of the calcium hydroxide is very low. There are two things control to use these chemicals. One is the price, easily accessible, and you can remove this calcium from the system. The couple of things help us to select the neutralizing reagents. Then, once we precipitate it, we have the lithium. Finally, we have the lithium impurity screen, pure lithium solution. Then we use sodium carbonate. So our target is to produce lithium carbonate. So we are using sodium carbonate to precipitate lithium carbonate. Now your question might be, why we use the sodium carbonate? Because in the periodic table, lithium and sodium both are very close to each other. So you are precipitating lithium carbonate by sodium carbonate. There is a little bit chemistry, the solubility. Might be you know the one term, solubility. So lithium carbonate under the certain conditions, the solubility is much lower than the sodium carbonate. That helps to separate lithium from the solution by using the carbonate. But nowadays we are using CO2 because lithium hydroxide is very good material compound to capture the CO2. So you know the global warming. So CO2 is the biggest issue nowadays to reduce that CO2. Right? So the lithium hydroxide, one of the very good compounds to capture the CO2 because it can make easily lithium carbonate under the certain condition in a solid form. So that principle we use in here to make the lithium carbonate by using CO2. But in these cases we use sodium carbonate. Once we get the lithium carbonate as a solid at 95, I told, under the certain condition means if the temperature is increased, the solubility of the lithium carbonate decreases. Means most of the lithium carbonate reported in a solid form, not liquid form. So over 95 degrees Celsius, its solubility almost close to zero. So we get most of the lithium as a lithium carbonate. That's why we increase the temperature about 95 degrees and do the solid liquid separation, and we have that lithium carbonate solid. We dry and make it lithium carbonate. That is ready to go for battery making industry. That is the commercial flowsheet currently using in the industry to make the lithium carbonate, the previous one. Then another group developed different flowsheet. Only the difference is, again, what are the other metals sitting into the resources, that is the brine. Depending on that, we use the different process steps. If the boron is there, the boron, B-O-R-O-N, the separation technology is little bit different. You can precipitate it, but it will end up to your waste material. But that waste material should be should have some characteristics before discharge to the tables. But if you are looking for very economically viable process flowsheet, then you should recover boron, because you can make a boric acid. It has a market. That's why we do the solvent extraction to remove boron, and we produce byproduct boric acid before moving to the neutralization. The lower part is very similar to the other one. There's a two flowsheet. or process steps we currently using in the industry to make the lithium carbonate, not lithium hydroxide, the lithium carbonate from the brines. The other one is hard rock, the solid material. Again, our target is to make lithium carbonate. The spodumene is the main mineral currently used in the industry to make the lithium carbonate, but the spodumene is very hard mineral to get the lithium out from it. Why? Because of that, the mineralogical formation, the metallic rearrangement, and the density of this mineral. The specific gravity of this mineral is 3.1 gram per cubic meter. Means it's very dense. It's not easy to extract because it is, we call in chemistry term or chemical engineering term, refractory to the acid. Acid is not easily attacked to this mineral as the density is very high. So initially this mineral in a form of alpha. So we call alpha spodumene. The density is high. What we do, we convert it into the refractory to non-refractory minerals by doing the treatments that I will discuss later. You can see in here how much the concentration of lithium oxide. There is a 6.8%. That is after doing the mineral processing. But the beginning it is around 1%. So many process steps. So it is not the lithium, we are making lithium ion battery by using the lithium carbonate. You should think before using, you should think, sir was discussing, it's not easy, but if you look at the background, so that sir came to the university, not in a one day or not in 1 year or not in a couple of years. He came up, overcome so many steps to reach that level. So the same way to this industry, so we're going to make, or we are making on every day changing the technology to make battery more efficiently. It's not the making battery only. There behind that so much history sitting in there to get those materials to make the battery. How much work is going in that industry? You can imagine to get the lithium carbonate to make the very good battery system to give you the energy. So much work people are doing to produce these materials, raw materials, to make this energy system. This is my flow sheet we develop in our place through BANS means initial work, then continuous pilot plant, then demo plant to produce the sound data. Is not only the chemical reactions, there is the physicals, means mechanical, electrical, and automation. Every system has all this integration. One is the chemistry. You should know what the chemistry, because of you using the materials, the metal, whatever is doing here. So the metal is based on the chemistry reaction we call process chemistry. The process chemistry integrated with the process engineering. So it's not only you should know that only the process chemistry, this one react with that one to produce this. It should be productable, it should be viable to make the product. That should control, that should follow some systems. That is the process engineering. So you need to develop the model to make sure your parameters are right. The model should be calibrated by the experimental data. You got my point, guys? So you need to develop the model. That is the engineering part. The model can develop the chemical engineer, model can develop the mechanical engineer, model can develop the electrical engineer, model can develop the IT guy. But they need to know based on what? What is your target? Target is to get the lithium carbonate from that ore. So all are integrated. This is the process steps we do. First one, the first left side, we do the mineral processing to get concentrate. What is the concentrate? Initially in the rock there was a 1 gram or 1% of lithium oxide. We increased the percentage to 6% by doing the mineral processing using that dense media separation or heavy media separation. Because of the density of this spodumene much higher than others. Then that materials, what will happen? You can ask me, why should not we use the direct materials? Then, instead of using the concentrate material, if you use the diluted material, means ore, in concentrate there is a 6%, in the materials, the initial material is a 1%. So your process plant will be 6 times bigger. Your cost will be so much high, production cost. So your capital and operating cost will be so high, you cannot afford to do it. If you want to make money, so your process flow sheet should be simpler. Risk of this process flow sheet should be minimum. Your cost should be less than what you are targeting. Then you can make money. Then your process flow sheet, your technology will be viable to run in industry or commercial plant. So that's why we do the physical separation, the easiest one, to make 6 times concentrate. Instead of dealing with huge amount, so you are dealing in a small amount, 6 times less amount of materials. That is easy to handle, at least 6 times easier than the first one. Then we heat to the 1000 degree or 1100 degree of these materials to convert alpha to beta. Because alpha is very hard, then beta is easier to extract. Then we move to sulfuric acid roasting. So why sulfuric acid? The metal is sitting in a hard form, but we want to bring this metal in a solid to liquid. So the acid is one of the media to bring this metal in a sulfate form. We use the sulfuric acid. Sulfuric acid is much easier to handle compared to the other acid. It's acceptable, and lots of associated risk and health and safety are already established. Then we mix with the water to make the lithium sulfate. But this lithium is not coming alone. There is so many other impurities that is also coming with the lithium. Then again this solution goes to subsequent impurities removal to remove most of the impurities from this solution before moving to the lithium hydroxide and lithium carbonate production. Why? How? By adjusting the pH. But if there is any amount of the calcium and magnesium in the solution, that will report to your final product. That's why sometimes we use the ion exchange technology, little bit different term, to purify solution and to make very, very high purity lithium carbonate. This is a pretty good flow sheet we developed. So we believe that next 5 to 10 years we will use this technology very rapidly in different locations all over the world to make the lithium carbonate or lithium hydroxide from the recycling materials. For example, you want to do the business on this industry. So what to do with that industry, these materials? So you're going to generate tons, hundreds of thousands of tons every year, lithium-based waste battery. So you need to know this technology to make that product, lithium carbonate, from these materials, and then move to the lithium-ion battery production. That is a very good and important flow sheet, we call flow sheet, or technology that is going to use in the next 10-15 years. Now what happening in every car companies, whether it is Toyota, Tesla, BMW, or others, Mercedes, they are working and spending so much millions of billions of dollars to develop their own technology like this one to keep in their cell to use next 10 to 15 years from their recycling materials. They're going to produce, they are producing, they're making battery-based electric vehicle, they're selling to the market, and their car will generate, their bus will generate so much waste battery. Their target is to collect all this battery, put in their industry, recycling industry, making their own product, that is the lithium hydroxide or lithium carbonate, lithium hydroxide and lithium carbonate they use to make their battery and then use in their product. That's the recycling thing happening. It will happen more and more. It will happen in this country too. So say, I don't want to do any job. I want to do the business. Business in what? Either in the energy industry or your aircraft industry or other industry. So there is all is integrated with the energy, right? So then the energy sector is looking for the alternative source of the energy, that is the renewable energy. You are not separated from this industry. Anyway, or directly, indirectly, you involved with this. This is another flow sheet. Ultimate goal is to make the lithium carbonate by doing different way. So what is the difference in here? So I forgot to tell you, so this lithium-ion battery is not only the lithium sitting into the battery, there is a cobalt, nickel, manganese, all these major base metals mixed with the lithium to make the lithium-ion batteries. So the source of these metals is constant. There is no new source. But every day we're going to use these materials more and more. So we need to regenerate, recycle, reproduce these battery materials for reuse. So similar to the lithium, so we need to recover cobalt, we need to recover nickel, we need to recover manganese and others and reuse these materials to make the new battery. This is another flow sheet. Instead of they're making the lithium carbonate, they also make the lithium phosphate. See, this is another product. If you look the lithium iron phosphate battery, there is a phosphate, the anion they use in that battery. How we make that the lithium carbonate or lithium hydroxide from the lithium ion battery? It goes to first physical separation to separate most of the hard part, that is the plastic and others. So there is a cathode and anode. In addition to that, there is a electrolyte. If you see the structure of the battery, there is a significant amount of electrolyte, and there is a separator. What we do in the physical separation before moving to that chemical separation to get the lithium, cobalt, nickel recovery. The separation process is different depending on the company is looking for. These are all about their business, nothing else. Every single flow sheet we develop, because sir came from the what's called the academic institute. The role or scope of that institute is to teach the student, give them the knowledge, and make them ready for the future, their life, society, and country. But the industry is also have. They do all these things in addition to they make a money. Whatever they do, the first thing they look, how can I make more money? So there is two different types of the research. One, academic research, enhance your knowledge, increase your knowledge by doing that. The other one is that knowledge associated to make money. The industry do that, the second one too. So that's why in the first world country, I believe you will go, a lot of the students will go to the North America, Australia or Europe, you will see so much industrial research is going on. When I was working in Atomic Energy Commission as a scientist, I was doing this routine work at some researchers. Or I saw that the university, my friends are doing many research, giving so nice, excellent, and nice way to share their knowledge to the student. This is very important. But when you move to the industry, that knowledge you are getting from the institute, that should be integrated to that market. That market will give you the money. So what they are doing in the Western countries, there is two types of research going on. Industrial research and development. They do that what's called market analysis. What markets currently in the different sectors. So for example, that renewable energy sector. Renewable energy is a big part. If you classify, there is a battery industry. Battery is used in everywhere. Whether it is in what's called renewable energy means solar-based energy or wind-based energy or electric vehicle. So it's a material. So it's not batteries only alone to make the battery. That should go what? There's a software, right? So electrical hardware and software are all integrated to one point to make it happen. Okay. So what do? They do the market analysis. What is the current volume of that market? What will happen next 5 years, next 10 years, next 15 years? Based on that, they contact to the industry, research institute, and universities to do the research, develop the technology, and then technology they use to make that their product, and they sell to the market. That's the things in the past was going on, and we are beneficiary to that. So because we are using the mobile phone, right? There's so many softwares. You are just one click. What is doing? We are doing. Currently, we are using their technology, but this is the guy who is doing. So we should be in that point. I believe we will be there, but it's taking time. But we should learn, learn from them. I'm sure, I'm definitely sure you will be a part of that industry today or tomorrow or next 5 years. So a little bit more chemistry, chemical engineering, process engineering, or electrical engineering part I'm going to talk. Now we talked about the lithium carbon production, but industry like lithium hydroxide, that's the best product to use to make lithium-ion battery compared to lithium carbonate. So lithium carbonate to make lithium-ion battery, so you are producing CO2, but the world wants to reduce the CO2, but your material is producing CO2. That's the key point. But if you use the lithium hydroxide, there is no CO2. That's why everybody wants to use the lithium hydroxide. But lithium carbonate is easy to make compared to lithium hydroxide. So how are we making lithium hydroxide? So they produce fast lithium carbonate that is easy to make. That is the source to make the lithium hydroxide by doing two different ways. One is causticization, means react with caustic to make the lithium hydroxide. Another one is there is the emerging technology we call electrolysis or membrane technology. So what happens in membrane technology? You're not drinking seawater. You're not drinking underground water. You always want to use the what's called bottled water like this one, right? So purified water. How these guys are getting the purified water? They use the membrane technology to remove most of the solid, suspended solid from this, and they produce the very pure water. That's what we are drinking. The thing in that way, it's integrated to our everyday requirements. So one way to produce the lithium hydroxide, that is the caustic reaction. Another is electrodialysis. Electrodialysis is the emerging technology now we're developing in that stage. Might be in the 10-15 years, this will be a dominating process to produce lithium hydroxide. This is the process currently using in the industry to make lithium hydroxide from the lithium carbonate. So how? So we use calcium hydroxide with water to make lithium hydroxide and monohydrate. That is the initial product we use for battery industry. And there is a chemical product that is the calcium carbonate. So we are using lithium carbonate, we are producing calcium carbonate and lithium hydroxide. The lithium carbonate has very, very low solubility. It's report to the solid, and the lithium hydroxide has a solubility high, and it is in a liquid form. This is the process they are using in the industry to make the lithium hydroxide. But this process is not more efficient. So there is a significant loss of these critical metals to the lithium carbonate. Because calcium carbonate absorbs some amount of the lithium hydroxide on the surface. And we are getting lithium hydroxide product. This is in a liquid form that is diluted. So to make the lithium hydroxide as a solid, you need to evaporate significant amount of the water. These are two disadvantages. One, we're losing lots of lithium metal with the calcium carbonate. Second, we are getting very, very diluted lithium hydroxide. To make the lithium hydroxide as a solid product, you need to evaporate so much water to get the concentrate to make the lithium hydroxide. So why? That is the disadvantage to remove the water because of the energy. The evaporation is not happening easy. You need to heat it up at 100 degrees Celsius close to. That's the boiling point of the water. But nobody wants to spend so much money means energy. Energy means money. So everywhere, the industry wants to reduce the cost. Because they want to sell their product cheaper. The other people can get the access and make that product more efficient. So to overcome these issues, we are developing other process flowsheet. One of my colleagues, co-worker, the Azimi, she is a professor of University of Waterloo. She developed this process flowsheet, and she published 2022 in a Elsevier paper. What she did, or her group did, so when these minerals dissolve in sulfuric acid, we get the lithium sulfate. That lithium sulfate, instead of using calcium hydroxide, they use barium hydroxide. So if you look at the periodic table, there is a magnesium, calcium, barium, rubidium, all this in one place. The barium has a special characteristics compared to the calcium. So barium more effective, more attractive, more reactive to the sulfate compared to the calcium. Then finally they produce the lithium hydroxide, but at the same time they produce barium sulfate. The barium sulfate is the waste materials, BaSO4. Then that barium sulfate can be heated at 11 to 13 degrees Celsius to get the barium oxide. That barium oxide is recycled into the mainstream. So it is closed loop. Is more efficient compared to the current existing commercial process flow sheet, but this is only based on the laboratory test work. This process should be run into the pilot plant, demo plant to generate the data. Then the data should use in a process engineering to generate or to make the pre-feasibility, then feasibility, then commercial plan. You might be know, but or you will know how the plant is built up. Any plant, any commercial plant, it should go to initial test work to generate preliminary data. Then develop like this flow sheet, this step, that step. Then that flow sheet tested in a continuous pilot plant, we call pilot plant. Then the data could be sent, but there will be lots of challenge. That challenge we want to know. Because this is a mining industry, this is the #1 conservative industry. Nobody wants to be a champion in this industry. Everybody wants to be a last person. Because billions of dollars involved with this technology or commercial plant. If there is so much risk, if there is a failure, so they're going to lose billions of dollars. That's why nobody wants to be fast, to use the fast technology, and new technology. They want to use the proven technology that is already tested. That's why we use the preliminary test work, then we develop this flow sheet, then we run the continuous pilot plant to optimize the flow sheet, then we move to the demo plant, then finally move to the commercial plant to minimize the risk, optimize that effectiveness. The other one is chloride, the brine. So we also use the brine to make lithium, battery grade lithium hydroxide by using sodium hydroxide. So now we do the why. So lithium hydroxide is precipitating with the sodium hydroxide by reacting with sodium hydroxide. Again, solubility of lithium hydroxide mass is smaller or mass less than the sodium hydroxide. These are the process steps we do in our place every day, every week to optimize different flow sheets. So that is the customization. I'm almost close to there, finishing. The other one is emerging technology, adapting from that desalination industry, water purification industry to this industry. So what is that technology? So there is a membrane technology we call. This is 2-compartment membrane and then 3-compartment membrane. The compartment membrane means there is 2 chambers. One is cathode, another is anode. There is 2 compartments. And 3-compartment means cathode, anode. In between cathode and anode, there will be the sample membrane. The membranes are the key component to produce lithium hydroxide. What happens in that case is mainly water is react to produce either in hydroxide or hydrogen ion, depending on the chambers. If it is in cathode chamber, we are going to produce lithium hydroxide, the water should produce hydroxide, and lithium is coming from the sample chamber to the cathode chamber to the membrane. Membrane is the key component that is giving only the lithium is passing through that membrane and others are not there, though this solution, feed solution, is highly pure. There's a two compartment membrane cell. The right side one is a cathode chamber, the left side is the anode chamber. The feed solution we use in these cases is lithium sulfate. We are recycling through this anode chamber and we apply the voltage. Then water is dissociated with hydrogen ion and oxygen, and lithium metallic ion or lithium ion is passing through the cation exchange membrane to the cathode chamber, where water is dissociated to produce the hydroxyl ion and hydrogen. That hydroxyl ion and lithium ion make the lithium hydroxide. This is very clean, very good technology, but expensive. It will give you much more cleaner product, but it has a limitation. Your solution, that is the lithium sulfate solution, should be clean. There should not have any calcium magnesium. If there is a calcium magnesium, your membrane will be fouled. Means what happening here, water purification system, they use the membrane, cation exchange membrane, anion exchange membrane, or the based on the pore size, they only design this membrane, only the water molecule pass through this membrane. But if the initial solution has other metals, after a certain time that membrane is blocked, the pore is blocked. If pressure is created high, the fouling is happened, then water is not produced. That's why they do some purification in the beginning to remove that impurities in order to move to the water production. The same phenomenon is here too. We use to make the lithium hydroxide. And we make 99.9% pure lithium hydroxide from our one European hard rock resource. You might be know, so we work for different companies to develop this flow sheet to meet their requirements. These are flow sheets we test in our laboratory, pilot plant, continuous plant, to ready for their purposes. That could be used in Europe. So we are working currently in a company, they have the property in Sweden and Denmark. And process flow sheet developed this one in a denser scale and pilot phase level, but still we are looking for the demo plant test work. This is the other one, 3-compartment membrane technology. The right side is cathode chamber, left side one the anode chamber, the middle one is the feed chambers. So these chambers are separated from each other by cation exchange membrane and anion exchange membrane. So again, the feed solution recycling, the lithium is moving from sample chamber to feed chamber to the cathode, and the sulfate ion moving to the left side. What happening in there? What is the difference between this one and the previous one? Here we are getting lithium hydroxide. There also we got the lithium hydroxide, but here we are getting sulfuric acid, and there was no sulfuric acid. There was a sulfuric acid with feed, but here sulfuric acid is fresh. So there is a byproduct of the sulfuric acid. This process is mass efficient in terms of the economics. So every single flow sheet associated with economics. You can develop a very good innovative technology if there is no economics, no value of that technology in terms of the industry. But for academic, yes, it's good. You learn something. But the industry, they want to know, so there is a learning point at the same time, the economics is there. Means they want to make money. They don't want to lose the money. So that byproduct gives them the money, additional money. The sulfuric acid. That sulfuric acid used in the front-end process systems. They don't need to buy every time the sulfuric acid. The process is generating all these chemicals. That's what we call the process should be, nowadays it is coming, should be economically viable and environmentally friendly. Otherwise, two things will not happen. One, if this process flow sheet or technology you want to commercialize, you need to get the environmental permission from the country. Every government has their own rules and regulations. If this technology does not fit or overcome or meet that conditions, they will not give you the permit. What to do with the sulfuric acid? Where the sulfuric acid goes, that has the limit for environment. So you need to take care of every single thing to report them. This is Process Research Ortech, we call PRO, my company's short name. We propose this technology for commercialization through the pilot and demo plant operation. What is difference this flow sheet compared to the others? The electrochemical membrane system is very similar, only with the integration with the other part, with this one. So we start from hard rock, spodumene, we produce lithium sulfate, we remove the impurities, we remove the calcium, remaining calcium and magnesium by introducing ion exchange technology. Then we feed to the membrane technology to produce sulfuric acid and lithium hydroxide. And after that, the lithium hydroxide concentration is a key parameter. In these cases, we can increase the concentration as much as we can. It increase, 1. That reduces the evaporation cost, energy cost to produce the lithium hydroxide as the lithium hydroxide is a solid. But it is not 100% recovery. None of the flow sheet give you the 100% recovery. There will be 10, 20, 15% in a liquid form. That need to be count to make this flow sheet more economically viable. That's why we produce lithium carbonate, another product, by using CO2, not the sodium carbonate. So there is no foreign ion in sodium. As soon as you use the sodium related any compound, so you need to take care of the sodium. So this is cost. This is environmental issue. So sodium carbonate is different than the CO2. So we capture CO2 and then we use that CO2 to make the lithium carbonate. That is not pure lithium carbonate, but it helps to neutralize, to remove impurities. That's why we recycle the lithium carbonate to the front end to adjust the pH. This is closed loop, very nice flow sheet. Hopefully it will go, but it is under patent pending. So everything goes to the patent because of the business. So concluding remark, I came to that close point. We know the lithium is one of the key metal and will play key role in renewable energy sector by using in the battery industry, whether this battery is used for electric vehicle or energy storage for clean energy, that is the solar energy or wind energy. Everywhere it will be used or using. And you can see that the prediction by 2030. So it will go to 80% from 24% in last 2019. The other one is we produce 99.93% pure lithium hydroxide monohydrate by 2-compartment electrodialysis using the last couple of bullet points you see. I did not discuss in details but you can see in here what type of membrane, cation membrane give us to make the 99.9% pure. That is the Lithium 119. There's so much business associated with it. We don't need to make the battery, but you can make this cation membrane by knowing the technology. It is so much market. The functional group, the reaction behind the chemistry, behind the metallurgy, behind the organic substance is different. So under these conditions and using these materials, we make 99.93% pure lithium hydroxide. That is very good for lithium-ion battery. So one more point I want to bring in here, for especially for the students. What's happening in this industry? This is an emerging industry, generating, producing a huge amount of new jobs. You might be not seeing here. If you go to America, Australia, Europe, you will see the demand of this skilled worker. These jobs are not that low-paid job. These are very good-paying job. We call green job, or American call blue jobs, high-paying job. Because the normal people not fit to this industry. They need to know certain things. It's a knowledge-based industry. So for an example, you can see that the graph, how much jobs is generating the clean energy sector or clean vehicles. 253,000 jobs in only one country, only in the battery industry. But clean energy is all these things. It's going to happen in all over the world, in every single developed countries. Okay. The important thing is for Bangladesh prospect, we don't have the natural resources that much, but we will have significant amount of recycling material. But most important thing is that we have so much powerful young generation we call human resources. If we give them right skills, knowledge, they will find their job. They will find their job within 2 weeks, 3 weeks, 1 month, 2 months. So, Sir mentioned that everything in a mobile. If you have that much skills, if you have the certificate, if you have the skills means I'm talking over here, hands-on skills. You know what to do. You know how to make it. That is the skill. So, there's so many challenges. As this presentation related to the technology, I just pick up the technological challenge. As I mentioned, we don't have the natural resource, but we have a huge and significant amount of human resource, the young resource. What we need to do, currently in Bangladesh, lack of skilled manpower. So we are moving to the solar energy system. We are moving to the green energy system. Who is going to do that work? You guys going to do. You will do. You are doing. So if you want to transfer current energy system to the renewable energy system by 30%, so who's going to do the work? So the young people will do this work. So they need to learn how to do that work. Lack of energy storage. So we're using what's called solar energy. We're producing solar energy. Then that energy directly should go to the current existing system to use it. But our climate is different. Sometimes there is a natural disaster and all other things are happening everywhere. So you need to store this energy. Means you need battery. That's the integration. So many points, especially we also need that R&D to develop our own technology. But you don't need to start from the scratch, it's already there. You should adapt from that technology and make it more viable with our conditions. That's the way we work. What we do? So we do that, what is the requirements in the market? What other people have done already? How they succeed? Then you know the current situation. Then how can we develop much more efficiently compared to the existing system? Then you think. So if you start from the scratch, it will take 10 days, but if you start from that current system, it will take 2 days, for example. But your materials or your product will be much better than the other one. That's the advantage. So opportunity, wherever the challenge is there, always there is opportunity. In Bangladesh, especially for Bangladesh, has endless opportunity in clean energy. We have so much human resource, just we need to give them the right education and right training. How the institute can do it? So, before answering that question, I will give you one example. So I live in Canada. I work in industry. Every semester, I hire 10 to 15 students to do my test work. That students come from different universities, especially Waterloo. Especially Waterloo is the best university for engineering. They design very different program compared to the others. Now others are following their what's called syllabus or curriculum. What they did? So 4 years undergraduate, they extend to 5 years. So every semester, every 2 semesters. So one semester they're in a campus, then another semester they goes to the industry to do the job. So 4 months in campus, 4 months in industry. Whether it is government industry, institute or private institute. Depending on their skills, their subject, their target, what they want. So what happened? The kids came to us, we hired them, but we paid them. Now question is, why companies pay? The one thing is, there is not a lot more efficient people to hire. Second thing is, government is subsidizing to every single organization to force them to hire the student. So when I hire one student, I'm getting 80% of their salary from the government through the students. It goes directly to the students' payment. So the government is helping, influencing to the industry to bring the kids from that academic institute to the industry. When these kids finish their undergraduate, they are so much smart. So one of my nephew, when I go there, he was an electrical engineer. He was working in a, everybody, most people use the Apple fourth generation. As a co-op student, he developed a software, a display software. He's one of the inventor of the patent. Before he finished, he hired more than 100K per year, 120K by Apple, working in Silicon Valley. Last 10 years, where is he? He is one of the director in Google. How he is? Because through this program, this is the one example. There's hundreds of thousands of examples. When they finish their undergraduate, they are skilled. They have how much? 2 years, 3 years, 2.5 years experience. in the industry. So what do we need to do? What we did, I just teach them for 2 weeks, or my engineers teaching them 2 to 3 days. Then we develop a procedure, health and safety, they follow the procedure and run the test. And 1-2 months, they only follow the procedure to run the test. After that, they are bringing their conception. Can we modify? Can we do better way to reduce the time and get more good results to satisfy the client who is paying rest of the 20%. That's the one example. That should be adopted slowly in Bangladesh if we are looking for that. It's not only the mining industry, every sector. Thank you very much. I'll be happy to answer your question if you have.
मैडम आपने बोला था তার কোনো কোশ্চেন
লিথিয়াম ব্যাটারি এটা বাংলাদেশের প্রোডাকশনটা একই মুহূর্তে করা যাবে লিথিয়াম ব্যাটারি প্রোডাকশন বাংলাদেশে এই মুহূর্তে করা যাবে র ম্যাটেরিয়াল পাবেন না
আপনাকে যেটা দেখতে হবে এটা মার্কেটে কত হ্যাঁ মাই প্রোডাকশন ইজ ওয়ান দেখতে হবে the market কত yes why not someone is using the battery and they are always looking for the cheaper way to make this battery. So if you have the cathode materials, if you have the anode materials, you have the technology, we can do the assembling in here. We can design that the framework and make it. Half of the company is the #1 battery maker in Canada. What they do, they bought the active materials from China. Why they goes to China? Because the cheapest one. And then let other things they do in our place. And then selling to the government, cars and buses, because they are currently buying most of them. And there is a margin, buying and selling bigger than the private sector, but others are coming soon. Yes, there is always opportunity, but need to look, assess the market. That's why the last point, we need to assess the current market. Then we need to fix what we can do next 10 years. Someone is making. Now, in this area, as far as I know, India is leading to make solar panel. Why not here? See, right now we can make the solar panel here. It's very similar to the garment industry, but the worker will be totally different. You need a knowledge-based, skilled worker. So that will not come one day. It will come slowly if we have a plan.
Sir, hardrock এবং ব্রাঞ্চের যে সোর্স ওইটা জানতে চাই hardrock প্রত্যেক আর ব্রাঞ্চটা প্রত্যেক আলাদা মতো কালেক্ট করেছে
So this is the naturally gifted. With nothing to do with this. God gave some places some material. The two source, that is the brine and other is rock. Some of the countries control this, but we will have so much recycling materials next 4 years. So if we are ready, if we have the technology, we can use that and make it.
Is there any research done in our country to find out the price, especially in the tidal zones of the country? Because there's a lot of slushy areas, salt areas even.
Yeah, when I was in Bangladesh Atomic Energy Commission, I was doing some research on seawater intrusion to the land, or it's called agricultural land. I saw that. And there is some papers. The salinity is go up in that area. If there is a salinity is high, there is more possibility to have lithium. Yes, we have some lithium, but we need to do that mapping how much lithium is it economically viable. If it is not economically viable, the professors, the researchers, they have to develop emerging technology to capture this lithium and make it economically viable. Yes, there is an ion exchange technology now we're looking for. You can use the membrane technology, just pass the lithium, keep other metals in the system, and then discharge to the sea and only get the lithium out. Yes, we can adopt. But lots of research need to be done. But immediate thing is that we can do that. A lot of businesses here is an emerging field. Every day is expanding. The funding is so huge. The government of the USA declared billions of dollars through the DOE. We are looking for that money too. We are submitting proposal to run our plant in North New York, Jamestown. We bought a 40-acre land to make the what's called graphite. 25% graphite is used in lithium-ion battery, minimum 25%. And the way it is using after by 2040, there will be no natural resource of graphite.
এখন পর্যন্ত সবচেয়ে কম খরচে লিথিয়াম রিসাইক্লিং বা যে প্রক্রিয়াকরণ সেটা কোন পদ্ধতিটা স্যার?
Okay, very good question. Every car company and others are looking for developing their flow sheet and optimizing. This is all based on the bench scale. None of them running into the plant because of the battery is not that much. Produce the waste battery to run the big plant. So again, if this active material made with lithium and phosphate, iron phosphate, the process will be much simpler than the active materials made with lithium, cobalt, nickel, manganese. So depending on which one, which is the active cathode material used in a lithium battery. But there is a possibility first to reuse it. So now you're getting 98%, maybe you will get 96%, but reuse it by doing some servicing. Okay? And then make lithium products separately, and then all product combinedly, and again you use that. There's so many research you can do and make an innovative product. Very good question, thank you. That's the things I'm doing and our group is doing.
ইউনাইটেড কলেজ অব এভিয়েশন তথ্য প্রযুক্তি ও বিজ্ঞান মনস্ক জাতি গঠনে অঙ্গীকারবদ্ধ।